Hi folks, this video is about truth functional form and the truth functional form algorithm. What I want you to do is try to place this sentence, not exists in x p of x, arrow exists in x p of x. Where do you think this would go in the chart? Pause your videos and try to figure that out. Okay, let's talk about the answer. In order to place this sentence, it's important to understand what the truth functional form of our sentence is. The truth functional form algorithm is a tool to help you understand sentences, complex sentences of FOL, and figure out what type of sentence they are, whether they're tautologies or contingently true or FO validities, etc. So let's talk about how to find the truth functional form of this sentence first, and then we'll return to the question of where it goes in the chart. The truth functional form algorithm is a tool to help you identify the truth functional form of this thing. And what it says is you first start by underlining the scope of the quantifiers. So the scope of this quantifier is narrow. It just covers the p of x. And the same with this one. So these connectives all appear outside the scopes of the quantifiers. And that's why I've underlined it like I have here. And then the next step of the algorithm says, replace the underlined parts with letters. Always start with the letter P. So I'm going to replace the first part with the letter P. And then if this underlined part is identical to this part, it gets the same letter. If there's any difference whatsoever between them, then the second part would get a different letter. But since these are character for character identical, they both get P. So this thing down here, not P arrow P, is the truth functional form of the original sentence. In a sense, what the algorithm does is something very simple. What it does is it hides everything inside the scope of quantifiers and makes us ignore it. And it preserves all the connectives, all the truth functional connectives, which are outside the scopes of the quantifiers. So the reason these things survive is because they're outside the scopes of the quantifiers. Everything else just gets hidden with these letters P. Now, let's do this. Tell me where this sentence here would go in the chart. Where do you think you would place this sentence? Is it a tautology, an FO validity, or what? Okay, I really mean you to pause your videos and figure this out. If you don't know off the top of your head, then I recommend doing a truth table for this thing. Okay, that was your last chance to pause your videos. If you do a truth table for this, what you'll discover, it's a tautology. It's true on every row. So this sentence would go in region 1. And here's the rule. If the truth functional form of a sentence is a tautology, then the original sentence is also a tautology. So that's where this sentence goes to. Now, this might be confusing because you might think, wait a minute, this sentence has quantifiers in it, so shouldn't it be an FO validity? But the thing is, the quantifiers are irrelevant to the necessary truth of this thing. These could be anything. All that matters is the structural fact that these two things are identical. The meaning of the quantifier is playing no essential role. In a sense, the negations and the arrow are guaranteeing that this thing is always true. The quantifiers don't matter at all. And that's why this is indeed a tautology. What's doing the work here is still just the truth functional connectives. FO validities are logical truths who are depending essentially on the quantifiers and identity, and this one isn't doing that. Okay, now let's try another sentence. Let's practice the TFF algorithm. So see if you can tell me the truth functional form of this thing. Okay, that was your chance to pause your videos. When we underline the scopes of these quantifiers, these connectives again get preserved. They are not inside the scope of the quantifiers. But because there's a difference between these underlined parts, remember we said in order to get the same letter P, they have to be character for character identical. And the difference in the variable X versus Y is not character for character identical. So that's the sentence down here, P or not Q. Now, this thing is not a tautology. If you do a truth table of this, it's not a tautology. So what that tells us is that the original sentence is not a tautology either. Indeed, let me ask you this. Can you figure out where it goes? Because it does not go in region 1. It failed the rule 1 test. So can you decide where it would go if it's not region 1? Pause your videos and try to place it now. Okay, that was your chance. Here's the answer is region 2. This is indeed an FO validity. Let's talk about why that's so. Even though the truth functional form of this is not a tautology, so the original black sentence is not a tautology, you might have noticed the variable switch equivalence can turn this into something which is a tautology. So this thing is logically equivalent to the sentence in red, which is necessarily true. But of course, just because this thing over here in red is a tautology, that does not tell us the original sentence is a tautology, because we have relied on not just the truth functional connectives, but on this variable switch first order equivalence. And this equivalence has to do with stuff inside the scopes of the quantifiers, namely that one variable can be substituted for another one. So that you can use those equivalences to help decide whether a sentence is necessarily true or not. But if you're relying on something that has to do with FOL, namely something having to do with a quantifier equivalence, then that convinces you it's necessarily true, but that doesn't tell you the tautology, it tells you it's an FO validity. So this, in a sense, is the second rule. Once a sentence fails the first rule and you know it's not a tautology, then you just have to look at the thing and think about what it means. And if you can use those equivalences, those FO equivalences about the quantifiers, to guarantee yourself that it's necessarily true, it would go in this region here. That it would go in region number 2. Okay, let's just practice one more truth functional form sentence to see if you've got it. So pause your videos and tell me the TFF of this thing. Okay, that was your chance to pause your videos. When you do step 1 and underline it, notice now we've got a differentiation. Some of these connectives are under the quantifiers and some are outside the quantifiers. So notice what the TFF of this thing does. It's not P arrow Q. The truth functional form, in a sense, hides everything inside the scopes of the quantifiers. So this arrow disappears, and this negation and this arrow disappears. We preserve this negation and this arrow because those are outside the scopes of any quantifiers. So in a sense, that the truth functional form algorithm just preserves everything outside the scopes of the quantifiers, because those are the true, that's the true truth functional form of the thing. Now, what you do next after finding the TFF of this is you do a truth table. And what you'll discover is this thing is not a tautology. But hopefully you could convince yourself still that this thing is necessarily true. Because look at De Morgan's for quantifiers. If I push this negation past the universal, it flips to an existential. So these two things are equivalent using a first order equivalence. So again, that convinces me that this thing is necessarily true, but because I'm appealing to an FO equivalence there that depends upon the quantifiers, this counts as an FO validity, not as a tautology. Okay, thanks.